So what's good, TMG fam? It's your boy Ellen, and I'm back with another reaction. How y'all feel? Welcome back to the channel. Salute. So, listen. Whoa. News time. Before we even get into the video, let me pull up what's going on. So, according to NASA, the Voyager 1's mission to outer planet is about to begin. That was sent to me yesterday. And then CNN sent out an alert. I'm getting them from everywhere at this point, bro. It's like funny how all of them know I'm into space now. You know what I'm saying? But CNN sends out an alert that NASA eyes 2 dates in late September for Artemis launch, but several hurdles remain. All right, so that's all I got for now. I'm gonna check out those articles once I'm done. But anyway, man, the next video we about to get into is you won't believe your eyes what the James Webb discovered. All right, so if you're new to the channel, hit that subscribe button, join the fam. Let's check this out.
On July 12, 2022, NASA released the first images taken by the James Webb Space Telescope. This in itself was a sensation, but a detailed analysis has revealed something even more extraordinary. James Webb has managed to capture an object that looks very similar to a Dyson sphere erected by an alien civilization around a star hundreds of light years away from Earth.
Now, what did that look like to y'all in the video?
Civilization.
What does this look like to y'all? This says deadly virus epidemics explained or whatever, but this looks like the video we looked at of the Big Bang, how it started off looking like that and then all of a sudden explode according to their theories. So now I'm thinking like, okay, could this be another situation? What we got going on? But they said this is a Dyson sphere, something totally different.
It's very similar to a Dyson sphere erected by an alien civilization around a star hundreds of light years away from Earth. Whether you believe this discovery is real or not, just admit it. You'd really like to hear that the telescope has sent us news like that. Besides, the Webb is soon expected to become the first observatory in history to shoot the most mysterious celestial bodies of modern astronomy that we've never seen before. What are those? Keep watching this video to find out. Apart from that, I'll tell you how the new telescope can revolutionize our knowledge of space. Thanks to the Hubble Space Telescope, we know that our universe is 13,770,000,000 years old. Meanwhile, the Spitzer Space Telescope has found some of the oldest stars. Up to this day, these 2 observatories were NASA's most powerful infrared eyes. In 2020, Spitzer had to retire after 17 years of service. But James Webb wasn't meant only to replace its colleague. NASA was developing the machine for 25 years in collaboration with the European and Canadian space agencies.
You don't realize how big the telescope is until you see somebody standing or a bunch of people standing around it. Every time I see that, I'm like, and it's like even more in awe of it.
25 years in collaboration.
Look at them standing in relation to it, fam. Because when they show it out in space, space is so, you know what I mean? It swallows this telescope, so it makes it look smaller than it actually is to us. But when it's here and it's put in its proper context and you see it here, you're like, yo, that's insane, the size of it.
Collaboration with the European and Canadian space agencies and spent on it $10 billion, all for the sake of unprecedented opportunities. Unlike Spitzer and Hubble, Webb perfectly detects near-infrared and mid-infrared wavelengths invisible to the human eye. The James Webb has proved its superpower by providing new pictures of the Southern Ring Planetary Nebula. The left picture was taken by an instrument called NIRCam that can capture infrared radiation at the shortest wavelength. This lets it peek through the clouds of ionized gas surrounding a dying star. As for the right photo, it was made by a hybrid of a camera and a spectrometer named MIRI. This mid-infrared instrument can take clear pictures of the shells of gas and dust. Later, NASA experts edit them to achieve natural color hues. Take a look at a photo of the very same nebula provided by Hubble. Feel the difference. If you check the picture of the Carina Nebula, you'll see why Webb wins by a mile. This one is a combined near-cam and mirror image. Look closely. Do you see
Look like a screensaver, right? Don't that look like a screensaver to y'all?
these hexagonal stars? This is Webb's trademark, and it has that shape simply because the telescope's primary mirror is hexagonal. It's composed of 18 hexagonal blocks. Each of them is almost 1.5 meters in diameter. In total, the mirror's surface area reaches 25 square meters. It's a historical record. Hubble's mirror is 5 times smaller, which unavoidably impacts the quality of the images and how many details they convey. Although Webb also has another advantage that makes it a truly cutting-edge telescope. Old boy Hubble needed 10 days to photograph these extremely distant galaxies. The Webb telescope completed the task in 12.5 hours and produced a brighter and clearer picture. That's because, unlike Hubble, it orbits the Sun instead of Earth near the second Lagrange point, or simply L2. The new observatory hides in our planet's shadow, so its cameras can see even very dim light. There's a problem though. Looking at the universe through the telescope's eyes, we'll see that the things glowing in infrared include Earth and Webb's own equipment, as we're talking about usual thermal radiation. Engineers knew that, of course, so they equipped James Webb with a giant sun shield, 21 by 14 meters. A parking lot of this size could fit 20 cars. But we'd better not experiment with this, as the shield is made of a thin aluminum coating and 5 layers of Kapton. This material,
Like, I respect the fact that they like crossed all the T's and dotted all the I's. Like, you know what I mean? For them to anticipate some of the problems that James Webb would face, they thought several steps ahead, which you have to do. So I continuously want to give them credit for that, because, you know what I mean, a lot of us, I can only speak for myself, sometimes it's hard for me to think 20 or 30 or 50 steps down the line, you know what I mean, especially into something that we're continuously getting information, so we don't know everything about it. So for them to continue look down the line and think about stuff that it could be presented with, because I'm pretty sure once they get it up there, it ain't no bringing it back and working on it, send it back out, bringing it back. This is an expensive mission, you know what I mean?
protects the primary mirror and exposed instruments from heat and cosmic radiation. The innovative thermal control system cools the main parts of James Webb to minus 223 degrees Celsius. This thing, along with the rest of the high-tech equipment that had never been installed on space telescopes before, makes Webb a perfect hard-to-find objects hunter. I'm almost sure you've missed one crucial detail in the photo of the Southern Ring Nebula taken by Webb. This nebula lies 2,500 light-years away from Earth, which means we see it the way it used to be 2,500 years ago. But there's an even more distant and ancient object lurking in the picture. Can you see this thin line? That's not glare or a camera glitch. Quite by accident, Webb captured a distant galaxy that we'd never heard of before. It had been hiding behind the Southern Ring Planetary Nebula all this time. At the moment, astronomers are frantically trying to calculate the distance to this new galaxy, and most likely, it's going to be millions of light years. Although, on a cosmic scale, this jump into the past will be pretty weensy. Back in 2011, Hubble took a picture of one of the oldest galaxies, located 13,400,000,000 light-years away. It shows us the universe just 380 million years after the Big Bang. Webb, in turn, managed to find something even older within the first months of its mission. In July 2022, scientists studied the new photos and spotted a galaxy called Glass Z13. That's apparently 13.5 billion years old. Webb was only warming up and already dived into the past 100 million years deeper than Hubble could in its peak form. When the space prodigy starts operating at its full potential, scientists expect to see a new universe with very young galaxies, 1 to 250 million years old. Their chemistry and even shape could forever change our ideas about the early universe. But we aren't interested in the first galaxies only. We want to know everything about the space between them, too. The Big Bang Theory states that our universe has been uncontrollably expanding since the moment it was born. The stars and galaxies that are not connected by gravity move away from each other every single second. If we figure out the exact rate of this expansion, we'll be able to not only glimpse into our world's past, but also predict its future. So, will Webb become our universal time machine? To make our dreams come true, Webb will first have to resolve the biggest cosmological dispute. The expansion rate of the universe is called the Hubble constant. Its units are kilometers per second per megaparsec. Astrophysicists found a few ways to calculate it, but here comes trouble. Results achieved by different scientific teams don't match up, like at all. The first team determined the expansion rate based on the cosmic microwave background. This is relic radiation left from the days when our universe was about 380,000 years of age. This way, the first team established that the universe expands at 67 kilometers per second per megaparsec. As for the second team, they explored the universe in its current state, in other words, adult. To be exact, they checked how the luminosity of well-known stars located several million light years away changes over time. Likewise, the rate of expansion of the universe, determined with the help of stars, against all logic, equals 74 kilometers per second per megaparsec. So, there's a 10% difference in the results, and nobody can explain it so far. Can James Webb determine which of the research groups is right? Sadly enough, the first team's cosmic microwave background is 100 times longer than the emissions the telescope can capture. It's kind of like trying to look at a python under a microscope instead of an ant. The good news is that Webb's mirror can collect enough light to detect the slightest change in the luminosity of relatively nearby stars. In 2022.
And see, that's the thing I was saying about Webb earlier. You know, they have to think so many steps ahead, and Webb, it won't know all of its capabilities until it gets out there and realizes, okay, I don't have the capabilities for this. Didn't expect to be met with this. Okay, now on the next mission and the next thing we got coming out, we can think for that and hopefully try to think a little bit more down the road. And that's how we're gonna have to continue to progress. But still in all, with its capabilities, oh man, we just getting started with what Webb can do.
Astronomers from the second team double-checked the results obtained with the help of Hubble and ended up with 73 kilometers per second per megaparsec. But there's still a difference. However, Webb is quite capable of closing this critical gap. And since the Hubble will stay out there up to 2030, it'll help Webb create an incredibly complex 3D model of the observable universe. And yet, whatever latest NASA news releases promise us, none of them mentions what the James Webb Space Telescope has really been launched into space for. Perhaps the new observatory will succeed in cracking the greatest mystery of modern astronomy. I mean, of course, that invisible and all-pervasive substance that fills the entire volume of space. Astrophysicists have long noticed that some galaxies move like they have much larger masses that even infrared telescopes can't see. The lacking invisible mass was called dark matter. According to most realistic modern assessments, there's 6 times more of it than all stars, planets, and cosmic dust combined. The well-researched gravitational lensing effect will come in handy, as it might help Webb find dark matter. This effect happens when a gravitational field of a massive body bends the light traveling towards it. Actually, we can see one of these lenses right in the center of one of the first pictures taken by Webb. Unlike Hubble, James Webb can spot even the most remote of them. And since it will notice much more distant galaxies, we'll have a chance to see even the smallest gravitational lenses. Physicists Matthew Walker and Anna Nierenberg believe this aspect will be the turning point for science and reshape our understanding of dark matter. Currently, the generally accepted theory says that only slow, heavy particles of dark matter can explain how galaxies formed and why they rotate so fast. Astrophysicists are absolutely sure that even our Milky Way has a huge, cold, invisible halo of dark matter. But if it does, there should also be small, dark clumps without a single star scattered all around space. And this is the best time for Webb to come into play. Hubble has already managed to detect small halos around distant quasars. Each of them is from 10 to 100,000 times lighter than the Milky Way. With Webb's assistance, Anna Nierenberg hopes to find the same objects in dwarf galaxies. In the meantime, Matthew Walker is determined to locate some exceptionally small clumps of dark matter with just 100 solar masses. Objects like that must occasionally perturb the orbits of stars in a binary system. It cannot be otherwise. Nothing can stop James Webb from seeing all those antics of cold dark matter. And yet, this is a dangerous game because if the telescope doesn't find any signs that these small clumps actually exist, we'll have no other choice but to toss all of our theories about the modern universe into the bin. On second thought, maybe the other dark matter hypothesis will save.
I feel like it's gonna be a lot of tossing things into the bin. The better we get, the further along we get, all them old theories I think is gonna come into question, if not be totally alleviated. Like, yeah, no.
Astrophysicist sanity. I mean the one assuming that primordial black holes could appear in less than a second after the Big Bang from high-density space areas. These prehistoric creatures could survive to the present day completely unnoticed. And since such a black hole wasn't formed due to a star explosion, it can be as heavy as a speck of dust or an entire galaxy with equal probability. In the early 70s, Stephen Hawking suggested that dark matter can at least be partly composed of those primordial black holes, although even Webb, however sharp-eyed it is, may have problems finding such objects on its own. It'll need a mighty sidekick to cope with this mission, like Doctor Strange in the latest Spider-Man movie. In 2034, NASA is planning to launch the LISA Gravitational Wave Observatory. It'll detect the slightest fluctuations that massive bodies can cause while moving. Then LISA will hand the notes to Webb. Going back to Stephen Hawking, he's also known for a theory even more extravagant than the one about prehistoric black holes. And if our telescopes confirm it, Copernicus' revelation that Earth is not the center of the universe will sound like a poor joke. Will the data collected by Webb confirm the speculation about other unknown worlds? First of all, I'm referring to other universes similar to ours. In 2018, the scientific world's attention was focused on Stephen Hawking's last paper, titled A Smooth Exit from Eternal Inflation, co-authored with Thomas Hertog. Of course, it's not the inflation that suddenly makes gas prices go through the roof. It's about cosmic inflation in the early universe. A regular explosion spreads evenly in all directions, but our universe suddenly started to expand exponentially soon after the Big Bang. In a matter of split seconds, it grew.
Every time they say expanding, I just think any minute, boom, just boom.
From an atom to infinite space where we send our costly telescopes like James Webb, even though there's almost no hope of uncovering where it ends. The problem is that, according to the eternal inflation theory proposed in the 80s, similar abrupt expansions keep happening in different universe regions. This could serve as a reasonable explanation for that huge difference between the expansion rates calculated by the two different scientific teams, but it's entirely at odds with the rest of cosmology. Don't forget that the eternal inflation theory insists that an endless number of new universes emerge out of nowhere. Oops, Hawking and Hertog trashed this theory in their article by proving that cosmic inflation cannot last forever. Just like economic inflation can make a gallon of gas cost who knows how much dollars. Consequently, it turns out that if other universes exist, there are not too many of them, and their laws of physics aren't as unconventional as they could be in an endless multiverse. Roughly speaking, you can have a different profession in a parallel world, but your national identity will be the same. What's most unbelievable is that scientists have found a way to check Hawking's multiverse theory.
So basically, I'm not doing reactions over there in that parallel universe. You know what I mean? I ain't doing reactions over there. I might be, you know what I mean? I don't know. Who knows, man? Billionaire by then. I'm striving to be a billionaire. So maybe I'm a billionaire over there by now. And in this life right now, I'm getting to there so I can be parallel over there. That's what I'm telling myself.
To do so, we must equip a spaceship with a special detector. It can find evidence of other universes in that microwave background left after the Big Bang. But remember what I told you, this wavelength is 100 times longer than what Webb can detect, so our dear friend is helpless here. Don't get upset though, you don't need any mythical parallel universes to see the most fantastic worlds. The best things are right here in our own galaxy. In 2022, there are already more than 5,000 discovered exoplanets. Not to mention, we have more than 2,000 possible candidates on top of that. But is this genuinely fascinating if all of them are lifeless? That's why scientists keep passionately searching for habitable worlds. Here's the point. If a planet has any live organisms on its surface, they will definitely leave behind typical atmospheric biomarkers. Above everything, these are molecules of water, ammonia, and methane. But the main surefire sign is the presence of chlorophyll. This pigment gives plants their green color and is vital for photosynthesis. Chlorophyll
I get excited because I think we're going to find chlorophyll, bro, for real.
absorbs visible light, and it's perfectly seen in the infrared. If Webb captures a spectrum anomaly on one of the exoplanets, this will mean that the place might have plants growing on its surface. In case there's an abundance of phosphine gas molecules, everything will point to bacteria able to survive without oxygen. Quite recently, astronomers have detected traces of phosphine in the clouds of Venus, but we'll need additional research to better understand its origin. Anyway, even the most powerful ground-based telescopes can't detect any of these biomarkers on other planets. They're simply blocked by the atmosphere of Earth. Hubble is practically useless here. Webb, in turn, can observe a 10 times wider...
Why they gotta do Hubble like that? Anytime a new shiny object or toy come along, they start trying to just down talk the previous, you know what I mean? Before Webb, Hubble was the apple of their eye. So don't start talking down on Hubble like that. I don't like that.
Practically useless here. Webb, in turn, can observe a 10 times wider portion of the infrared spectrum. And if there are any biomarkers on exoplanets, it'll spot them. But anyway, astronomers' #1 dream is to discover a highly developed civilization with its own unique markers. If aliens search for people, they can find us by a very high concentration of carbon dioxide and monoxide, ozone, and lead in our planet's atmosphere. However, before we get lucky to witness such a fantastic discovery, the James Webb has every chance to rewrite yet another chapter in the astronomy book. Remember that mysterious picture I showed you at the beginning of the video? That's how one of our old telescopes sees an exoplanet situated near a distant star. And the truth is, we were thrilled to have even this barely visible dim dot. Webb will not only let us have clearer optical images of exoplanets, but also get our hands on something extraordinary. Can you see this blue object? No. That's not a Dyson sphere. That's how the most elusive object in the galaxy will look in Webb's photos. This object is an exomoon. It'll be a mind-blowing discovery, as to date astronomers have never succeeded in finding satellites near exoplanets. The driving factor here isn't just pure curiosity. exomoons orbiting gas giants can turn out to be even bigger than Earth, which potentially makes them perfect cradles of extraterrestrial life. If there are about 1 billion terrestrial planets in the Milky Way, there might be many more similar exomoons. In short, we're closer to discovering at least a primitive life form in one of the different worlds than we've ever been. This will be Webb's most priceless gift to all of humankind and the best possible return on our investment. Considering the first unexpected discoveries made by the telescope, it's safe to presume that Webb has already captured some habitable world. Maybe we'll learn about it as soon as scientists process the pictures. And what if NASA experts have already found something unbelievable in those images and just keep hiding it from the public eye? Being bombarded by the news about the first images from James Webb, you could naturally miss that the agency is urgently developing a new project. NASA is launching an even more advanced telescope called LUVOIR. It took about $10 billion to build Webb, but this time around, scientists are clearly on a next-level spending spree. The preliminary cost of this observatory is estimated at $18 billion. LUVOIR is scheduled to launch in the 2030s, which, in the world of space missions, can be called a super speedy project. What's the rush? And why so much money? NASA's already revealed that LUVOIR would be equipped with...
That's what it's all about there, the money.
Eclipse, a special, highly sensitive coronagraph. This device will block out starlight that partly spoils Webb's pictures with hexagonal patterns. What's more, LUVOIR will have a brand new feature called multi-object spectroscopy, as well as the LUMOS FUV system, meant to simultaneously analyze the chemical compositions of many exoplanets. As a result, LUVOIR will be able to detect markers of extraterrestrial life in the atmospheres of several exoplanets revolving around sun-like stars. Sounds crazy, but what if, after studying those images from Webb, that the agency decided not to publish? NASA isn't just sure we're not alone in the universe, but also suspects that we may have many neighbors. Feel free to share your ideas in the comments, and don't forget to mention what incredible discoveries you hope to hear about when James Webb returns from its 20-year mission.
It's the thrill of the chase, right? Is what we do when we catch it. You know? Everybody, it's fun to dream, think, and wish or hope or think of the possibilities of finding life, but what happens if we do find it? You know what I mean? I know a lot of us have that perfect picture in our mind of, oh, they're going to be so welcoming and their technology is greater than ours and they're going to share it. Life is going to be so much better. It's a flip side to everything, bro. You know what I mean? It's a good and a bad. But until then, let's enjoy the moment, the data, and see what happens. And we'll just leave that at that. But y'all get at me in the comment section, man, and let me know what you thought of this video. You won't believe your eyes of what James Webb discovered. All right, it's your boy L. Till the next one, I'm gone. Peace.